Alright then, we're going to create a TensorFlow deep neural net model. So how are we going to do that? The first is define the model, like build the graph. If you look at my earlier videos on TensorFlow, it tells you to build the graph in TensorFlow. Once you have the graph ready, then you train the model. So build the graph, train the model, and then while training, the model creates checkpoints, something like this. So it creates checkpoints, CKPT, with index and meta, and these model checkpoints are iterations. So TensorFlow by itself creates iterations of models, and it creates checkpoints. Now once the model has finished training, we can evaluate the model. And please remember that the problem we are trying to solve here is a regression problem, and therefore we're going to base our facts or base our performance metrics on root mean square error, which is RMSE. Very simple: build, train, define out directory. So build, train, and evaluate are the steps, and train out directory is our parameter. So we are going to use this something which is like this. So this is a parameter which we have to set, and these are the steps. So build, train, and evaluate. Let's see how we do that. So let's look at, we're going to import sh script shell util import datetime, and it's not required here, but anyways, tf.compat, we are using a v1 logging facility for logging information, and then I'm defining an out directory which is yellow caps. So out directory is going to be defined as yellow caps, and then I'm gonna, first of all, it says shutil remove tree. That means if there is a pre-saved model on out directory, just remove it. Just clear the directory. So it's gonna be a fresh start. So all I'm doing is creating an out directory folder and removing everything inside it. Now remember the build. So this is building the graph. I'm building as DNN, deep neural net regressor, because we are doing regression. And then within that, I'm defining parameters like hidden units. I'm arbitrarily picking up 64, 32, and 2. We will see in the next feature engineering steps and hypertuning how we are changing this. But for now, I'm picking hidden units. So remember, the neural net are part of neural net model are part of a big neural, I mean, it consists of neurons, and this is 64 neurons in one layer, 32 neurons in the second layer, and 2 neurons at the third layer. Then I'm defining feature columns, tf.feature.column. Please remember that for neural nets you only have numeric columns as inputs, and then model directory is nothing but yellow caps. So three things: hidden units, feature columns, and model directory. Next, so build is done, we have to do train. So this is your train. So model.train input function. Now all I'm doing in this input function is defining what is my x train, what is my y train, batch size. If you remember, we talked about TensorFlow. It is an iterative fashion. Epochs is the number of times you want it to go through your data set. So number of epochs is defined as 5 or 10, and then sorry, it's 100 here. So you can define a number of epochs. I'm passing here 100. Batch size you can define yourself, but for now I have kept 128 as batch size. Shuffle is false, and number of threads is equal to 1. Shuffle is false, and number of threads, for now I'm just keeping number of threads is 1. These are the parameters where you define so that you can train the model. Once the model is starting to train, remember it will generate checkpoints, and I'm going to show you the checkpoints as soon as the model starts training. And finally, evaluate. For evaluation, I have defined a print RMSE structure, a function in which all it is doing is it's evaluating. So I'm going to call this function print RMSE from as passing through a model test, x test and y test. If I pass on this, it's going to calculate the RMSE. RMSE is root mean square error, and in my previous set of videos I have defined what is an RMSE there. So please go take a look. I'll put down the video description, a video link in the description section of the video below. All right, let's get on, and once we come back we'll talk about the hands-on exercises. So let's go back and run the code right then. So what you got to do is you can go to the shared location. The link of Google Drive is mentioned in the video description section, and use this TensorFlow trainer deep neural net model -DIY number 3. Now this is your build. So I'm going to run this, import shutil, import datetime. Remember I defined an output directory, yellow caps. It's going to be available over here. You can see yellow caps, and then ignore this line, these lines for now. This is for tensor board, which is I'm going to explain it in the next video. So ignore these lines and run the DNN regressor. This is the build model. When I ran this, I got the output here like this. So these are hyperparameters for building this graph. Service timeout, cluster spec, worker. Just go through it. It's very important you to just take a look at it. Next is the train. So when I click on this, this is your train. I'm going to pass the train, X train, Y train, the batch size, number of epochs, shuffle false for now. You can make it true. It'll shuffle the data, and then number of threads is 1. And if I look at the logs here, I'm just going up. So it starts doing its fun, and you can see that it's saving checkpoints. So TensorFlow runs in batches, and 100 epochs, 100 times it's evaluating and the entire data set, and you can see that the loss is 136. Just to let you know that the RMSE, which is root mean square error, is square root of average loss. So I'm gonna calculate the RMSE. I have already run this before, so you can see that RMSE for this was 14.84. So square root of average loss is around 14.84. Average loss is 220. No, I'm sorry, this is your training average loss, and if you look at it, the average loss during the testing, the evaluation is 220. So square root of this is 14.84. So what I'm trying to get to here essentially is, if you use this model to predict what would be the fare from point A to point B in Chicago, most likely you may get an error of $14. That's not good. I want to improve the accuracy. So $14 is my average, plus or minus $14. It's too much, right? If the fare itself is $20, you have $14 as the possible error, anywhere between -14 to $14, 14.84. It's not good. What can we do? The answer to that is feature engineering, and that is going to be our next step, in which we are going to improve the accuracy of the model, probably bring it down to $6 or $5 or even $4. So if I have a prediction to make, I can predict within an error range of plus to minus 4. So if the cab fare, the taxi fare is going to be $30, my model will predict in the range of $26 to $34, which is very, very effective. So for now, RMSE is 14.84. Let's go and look at the hands-on exercises, and then we are going to talk about TensorBoard, which is how you get into really the nuts and bolts of understanding the TensorFlow in detail. All right. All right. So hands-on, make a copy of this Python book, which is number 3 now. Try changing various parameters like batch size, make it 128, 256, 512, and see if you change the hidden units, remember, from 64, 32, and 2 to 128, try changing it, and number of epochs too, and see what effect does it have on RMSE. Does the RMSE go down or go up? And this is an iterative process you need to be really mastering on. And by the way, think of automated iterations. Think of those. We will talk about all this in feature engineering, which is going to be the following videos. And then how to track the training in a graphical format. The answer is TensorBoard, and that is going to be our next video, understanding and playing a little bit around TensorBoard. Till then, hands on, make your hands dirty.